All right, let's get started. Welcome to the session on 12 ways to make code suck less. I'm going to talk about code quality and how we can improve what we do. I'm going to start by saying there are four kinds of people. There are the how kind of people. They want to know how you do things. Then there are the when kind of people. When are you going to get it done? And then the what kind of people. But I'm more of a why kind of a person. So I'm going to start with the question, why should we really care about code quality? And as it turns out, that if you really want to be agile, you cannot be agile if the code sucks. You're sitting in this meeting, and they're talking about making a change to this XYZ module, and you realize the last time you touched that code, you couldn't go home for the weekend. You're going to convince people that you don't want to make this change. So code quality is extremely important if we want to really maintain agility, especially sustainable agility on our software projects. But then again, I was thinking, why should we really care about code quality? And as it turns out, there is yet another reason why we should really care about code quality. Because code is how we tell our colleagues how we feel about them. Do we love them, or do we hate them all? So this really matters. How we write code is how we communicate to our team how we feel about them. Well, it turns out that the first law of programming says that lowering quality lengthens the development time. So if you really want to go slow on a project, write really nasty code, it slows you down automatically. If you really want to go faster in development, code quality is extremely important. But then, of course, the question is, what is really code quality? How do you define code quality? I'm sure if you ask 10 people what code quality is, you'll get 10 different answers. I'm okay with most of the answers, except the one I got from a colleague of mine. And he said, this code is great because I wrote it. I don't think that's a good definition. So what is a good definition of code quality? Here's my definition. I'm going to say the quality of code is inversely proportional to the amount of time and effort it takes to understand it. If a code is of really good quality, you take less time to understand it. If a code is of poor quality, you take more time to understand it. I do a lot of code reviews, and I often tell my developers, if I spend more time on your code, that cannot be a good thing. You want to be able to write the code in a way we can grasp it very quickly. So with that said, I'm going to talk about 12 different ways to create better quality code. I'm going to count down from 12 all the way to 1. So here's the first one. The 12th point, schedule time to pay technical debt. Well, we all talk about technical debt all the time. Ward Cunningham created this term based on his observation of the financial industry. In our communities, we have the technical debt as well. Now, we all know that we have technical debt. I'm not going to ask if we do have it, but when I go to companies, I often ask the question, where are your technical debts listed? So when I go to teams, I want to see the technical debt listed on the wall. And I want to see them listed in the order of the most troublesome to the least troublesome, listed on the wall. One of the reasons I want to list it on the wall, instead of just assuming we have it, is when you're sitting and writing code on that Wednesday afternoon, you can ask your colleague, are we taking a shortcut? And if we do, is our code that we are writing right now going to end up on that wall next week? So it gives us an ability to be aware of the quality of code as we write it. Secondly, I want to say, schedule time to pay technical debt. Now, of course, if we don't take the time to pay technical debt, software projects lead to what is called technical bankruptcy. So we want to really be able to pay off these technical debt along the way. So one way to do that is to schedule time for it. So we could say, for example, he's going to spend 15% of his time in the next iteration or sprint in the first debt, and she's going to spend maybe 10% of her time on the second debt, and so on. And so we can start scheduling time to pay technical debt. So in a project, we typically schedule time for various things. For example, for development, for meetings, for vacation, sickness, and so on. Well, we certainly want to spend time on these technical debt as well along the way. The next thing I want to talk about here is to favor high cohesion. So what is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. Now, why should we really make code cohesive? Well, it really comes down to frequency of change. A code that is really highly cohesive changes less frequently compared to code that's less cohesive. Now, how do we know if a code is cohesive or not? Well, one of the ways to observe this is to look for the cyclomatic complexity of code. So if a code has low cyclomatic complexity, it often has high cohesion, which is a good thing. Now, this reminds me of an experience I had with a project. This company, they have been developing this software for a good 30 years. It's a bit nerve-wracking when I go to this company because there are people who wrote the first line of code still working on this particular project. Now, one of the developers called me out and said, let me show you something, and he said, and can you imagine a version control with 30 years of code in it? And he takes me to 15 years ago, and he shows me a function, and I was blown away by this function. Beautiful looking function. It had a very nice name, only 2 parameters. I could see its entire naked body in front of me. It was the day this function was created. And I was admiring this function, and he showed me the cyclomatic complexity of this function, a value of 5 when 10 is considered to be really complex. As I was admiring it, he said, don't get carried away. And he started moving the timeline from 15 years ago to the current date. And as he moved the timeline, that beautiful little code turned into a monster in front of me. I could no longer tell how many lines of code it had, and don't even ask me how many parameters this took. And the cyclomatic complexity of this particular function was a value of 864. And then he said, that's what we do to code in this company. And I wanted to really find the exit and run away. Well, of course, if we don't take the time to refactor the code, it turns into a monster over time. So we need to really look for the cyclomatic complexity and keep it low so we can keep the cohesion really high. We also want to make the code loosely coupled. Now, we all can agree that loose coupling is a good thing. Why? Because if a code is tightly coupled, it becomes really hard to maintain the code. It becomes hard to test the code as well. I'm a huge fan of testability of code because that's an early warning sign that something could possibly be wrong with the code. Now, of course, when it comes to loose coupling, we can say that depending on an interface is loose coupling, depending on a class is tight coupling. But I want to go a little further with this. I don't want to just loosen the coupling. I want to eliminate the coupling where possible. Now, why should we eliminate coupling? Well, this reminds me of an experience I had with the conference where there was a discussion about why testing is so important, and yet developers were not able to write effective tests because of all those mocks and stubs they had to create. And listening to them, I came to realize one thing, though. Well, the more stubs and mocks we use is a sign of bad design, so I would want to really use fewer mocks and fewer stubs. But this really comes back to rethinking about dependencies. For example, if you look at this example here where the code in the middle is the one we are interested in testing. Now, the code in the middle is really hard to test because it's got a dependency on the code on the right, which is unpredictable, hard to work with. In general, code that is not idempotent is really hard to work with. Now, it turns out that when we look at the code in the middle, it not only has one input coming in, it actually has another input, except it's fetching the data. We can rework this dependency just a little bit. By moving the dependency around, we can eliminate this direct dependency of the code in the middle with the code on the right. And as a result, it becomes a lot more easier to write tests with this piece of code. And as a result, we would need fewer mocks and fewer dependencies. So in general, rather than focusing on creating loose coupling, I would actually encourage developers to remove coupling, or at least move it around to another location so it becomes easier to test the code with it. Now, obvious question here is, by moving this around, did we gain anything? And the answer is yes, we did actually gain a big deal. And the reason is, if you look at this code, this coupling on the right side is fine-grained. Every single test is going to require a mock object or a stub. On the other hand, this coupling on the left is more coarse-grained, and as a result, it doesn't really require as much stubbing and mocking, so we actually gain by moving dependencies around quite a bit. So we talked about 3 different things here: scheduling time to pay technical debt. We also talked about keeping high cohesion and low coupling. Well, the next thing I want to talk about here is to program with intention. Now, clearly, we know this along the way. As we write code, sometimes we are so eager to make the code to work, we try all kinds of things to make the code work. Like, I remember working with on a new project with a client, and I was trying to refactor the code. And as soon as I did, the test failed. And I looked at my colleague and said, look, the test is failing. What do I do? And he suggested to try an index +1 as a variable. And I tried, and the test failed. And he suggested, why don't you try index -1? And I looked at him and said, are you serious about it? And, well, he said, maybe we should understand what the code is doing. What a great idea. So sometimes what we do is not programming. It's called working in desperation. We're just trying to get this code to work. Now, I'm sure everyone in this room will agree with this programmer sentiment because we all have been this programmer at some point in our life. And the programmer, out of desperation, said this. He said, when I wrote this code, only God and I understood what I was doing. Now God only knows. So this is so true, isn't it? We all see this every single day. You look at a piece of code and you don't have a clue why this code is working, and that's really frustrating when we come across code like this. So how do we really write code with intention? I'm a huge fan of this so-called 4 Principles of Simple Design by Ken Beck. And Ken Beck talks about very simple 4 rules, and I try to follow these 4 rules almost every single day I sit down to write code. And the 4 rules he talks about for simple design are, A, the code passes all the tests, and secondly, the code has reveals intention. Third is that it has minimum duplication of code, and then finally he says it's got the fewest elements. So the code passes all the tests, has ability to reveal its intention, doesn't have any duplication, and of course, fewest elements. I'm a huge fan of the last one, especially where we're working towards minimalistic design, but it puts it in the order of priority from the high to the least in this case. This is one of the reasons I'm a huge fan of writing tests before writing code, because it helps me to rethink about my intention as to what I want this code to do before I dive into implement the code itself. And as a result, we can make sure to focus on the intention and to reveal the intention more so than simply just to write the code as it comes to mind. With that said, the next thing I want to talk about here is to avoid primitive obsession. Well, we all deal with this every single day. We sometimes write code at the lowest level. We sometimes write code without really thinking about higher levels of abstraction. Now, recently I was reviewing a piece of code, and it was only about 30 lines long. And I was reviewing the code. I was a little surprised. Something bothered me, but I couldn't explain why I was unhappy. And then I kept reading this code over and over, thinking what I was really unhappy about. And then I realized this 30 lines of code was written to manipulate a string. And I thought to myself, gosh, this cannot be the first time humans have tried to manipulate a string. So I did a little search, and I found that there's actually a function in the JDK that actually does this code already with 2 differences. One, that code in the JDK did not have the bug this code actually had. The developer had taken the time to write it. And why bother wasting the time reinventing the wheel with the bug when it already exists? So all I did was I commented the code out, made sure all the test was passing by calling the JDK method, and I checked in the code, didn't do anything else. Well, an hour went by, the developer came along, looked at the code and found out I've commented out almost all the code he had written, and he thought about it for a few minutes, removed the commented code and checked it back in. That's a nice way to communicate with the team. Well, these days I go to my developers and ask them a very important question. I tell them when you sit down to write a piece of code, ask this very important question: are you the chosen one? If you are the chosen one, you should write this code. But if it's a general purpose code, with all respect, somebody else was chosen a long time ago, and maybe they did a better job. If it's very domain specific and application specific, the chances are you're the chosen one, you should be writing the code. Well, I'm going to say that imperative style of code is packed with accidental complexity. We have to deal with 2 kinds of complexity on projects in general. One is called the incidental complexity. These are complexity that come from the problem domain, from the application. There's nothing we can do about it. But the second type of complexity, unfortunately, we deal with every single day is the accidental complexity. This comes from the solution space. And this really makes our life hard for us to deal with. Let's think about this a little bit with a little example here, if you will. So here is a little function I have, is prime. But here's a piece of code I really want to implement. Let's implement this using the familiar style of code, which is imperative. So here's the compute function. What does it want to do? It says compute the total of the square root of the first k prime numbers starting with n. Hey, that's not rocket science. That's a very simple code, isn't it? The total of the square root of the first k prime numbers starting with n, how difficult could that be? So let's give it a try. So I'm going to say double result is equal to 0. I want to return the result when we are done with it in the very end of this function. Then what am I going to do? I'm going to say int index is equal to n, which is the starting number. I'm going to say count is equal to 0. So what did I do so far? Absolutely nothing useful. All I wrote was some stupid variables. These are called garbage variables. I know what you're thinking. You're thinking, gosh, I don't write code like this. I normally write code with an R, not a result, with an I, not an index, with a C or a F or a T, because that's how we tell code that it doesn't deserve to live. These are really garbage variables. We don't care about them. Fair enough. Then what do? While count is less than k. At this point, you come to a grinding halt, and you ask the question, is it less than or equal to? Do you ever ask this question? Every single day. Somebody asked me, what is that symbol called? I said, that's the international symbol for confusion. Because every time we write it, we pause and ask the question, huh? And we're never sure about it. And this actually takes a toll on us, because you write the code and you're going to the bathroom. And as you're going to the bathroom, your colleague passes by and says, hello. You don't say hello right away. After a delay, you say, well, hello, because your mind is still processing that. You're at home having food. Your family says, are you okay? Yeah, I'm fine. You look really tired. I'm fine. Is everything okay at work? I'm fine, all right. Just not sure if it's less than or equal to. We keep thinking about it all day long, isn't it? Then what do? You say, if e is prime of the value, which is the index, then what am I going to do? Oh, simply result plus is equal to, and I'm going to say math dot square root of what? In this case, of course, square root of the index. And I'm going to go ahead and write that code. I'm going to ask the question, is the code correct? What do you think? No, what did I miss? Oh, yes, increment the index, thank you. What else is it correct now? Oh, no, increment the count, all right. Count plus plus, is it correct now? And you're like, no, it's got to be outside. Oh, of course, thank you for saying that. It's got to be outside. So let's move it outside. So what am I going to do? Take this outside of the loop. There you go. And you say, no. One has to be inside, one has to be. How do you feel about that? That is called accidental complexity. Now, is the code correct now? Did you notice you went from saying no to, wait, I'm thinking? Now, this is the beauty of imperative style code. And I've come to a realization over time. Programmers are the smartest people on earth. Because you show a code like this and ask them if it's correct, they will never tell you it is correct. They'll always tell you it looks good. Because they know that in 3 weeks' time, it probably is not going to work. So I'm going to run the code and see what it does. It gave me a result. You could ask me if it's correct. All I can tell you is it looks good. Well, this is an example of an imperative style code, and I have this theory. And the theory is it's a code like this that prematurely turns programmers into managers. Because they say, I'm done. You guys can play with this. I'm going to leave. Now, I'm going to say this. Those of us in this room who are programmers, there's a name for each one of us. We're called the survivors. Because I know this is a little hard, but think back in time. The very, very first day you wrote your very first line of code. Remember that day? You wrote your code and you said, oh my gosh, I'm a programmer. And the person next to you says, did you compile it? And then you're like, damn it, what does that mean? And then you run the compiler, and what does the compiler do? It literally spit on your face. And you were in a shock. You said, oh my gosh, what is it? And you wipe the spit. And then he says, or she says, welcome to being a programmer. And you wrote the code, and the next day you wrote code, what happened? The compiler spit on you some more. And you worked on this code for 15 years. And then what happened? It still spits on you, but you just don't give a damn anymore. That's called being a programmer. Programming is not for the faint of heart. Well, we deal with all this complexity every day, but doesn't mean we have to. Let's give it a try one more time. Let's go back to this code and see maybe there's a better way, a simpler way to write this code. So what am I going to do? I'm going to say return, and I'm going to start with the stream.iterate, and I'm going to say, in this case, stream.iterate, and I'll start with the number n, which is given to us, and I say, given a e, return e plus 1. Let's stare at that one line of code for a minute. What in the world is that? That's called an infinite stream. What is an infinite stream? An infinite stream absolutely has no bounds to it. It starts with n, n plus 1, n plus 2, n plus 3, n plus 4. It keeps on going. I know what you're thinking. You're thinking, oh my gosh, if it's infinite, where in the world would you store it? On the cloud, of course. But the point really is, it's an infinite stream. So then you say dot filter, and you say sample is prime. So you start with all the numbers that start with n, but you only get prime numbers that start with n. Then you perform a map to double, and you say, give me a math square root of all that value. Then you say dot limit, and you say, wait a minute, is it k or less than, or it's k, damn it, keep moving. Don't have to worry about it. So as a result, when you run the code, it produces the same result as the other piece of code did. Now, when you look at this code, notice how it is so simple to read, simple to understand. It's a one pass through the code. Given all the numbers starting with n, give me only the prime numbers, but give me the square root of them, but give me only k of them, and you total it. That becomes a lot easier to work with. So in other words, a good code should read like a story, not like a puzzle. Now, when you write a code that's a puzzle, what happens? Everybody around you doesn't understand it. Sometimes they invest a few hours to understand, sometimes a few days. In the worst case, it may be even few weeks before they figure out what the code is doing. I'm sure you've seen a share of it, your share of it. On that Wednesday afternoon, you're working in your cubicle, when you suddenly hear this scream from the other building, and then you say, they got it. So that takes a lot of time for people to understand what your code is doing. Well, if you write a puzzle, unfortunately, when your team figures out what the puzzle is, they don't be quiet. They return the favor to you, and they create their own puzzle for you to solve. In the meantime, we got production code to release. So I want the code to read like a story, not like a puzzle. Well, this is one of the reasons I'm a big fan of functional style of programming, because in the imperative style, you focus on what to do, but you get dragged down by how to do it. In the functional style, it's declarative. You focus on what to do and not on how to do it. As you can see here, the functional style is built on declarative style, plus the use of higher order functions, so it naturally fits in really well with a very descriptive way of writing code. With that said, I'm going to say prefer clear code over clever code. Now, let's be honest about it. We all have written clever code. Why do we write clever code? I'll tell you why we do. Because it feels so good when you write code that nobody can understand. And everybody scratches their head and says, it works, but I don't have a clue. How did you do it? And when you write such code, you go home and you tell mom, Mom, I wrote this code today and nobody understood it. And mom gives you a hug, isn't it? And says, I know you'll be brilliant one day. Well, that's unfortunately misguided where we put in. We really need to focus on writing clear code, not clever code. This reminds me of my own experience. You know, they say experience is where you try all your things before your luck runs out. Well, I was on a project when the client told me they need to make an enhancement to the code. I looked at it and said to myself, oh my gosh, I can do this in 10 minutes, but why would I? I don't want to solve this problem. I want to solve the mother of all problems. And I spent an hour solving it. And when I finished it, it felt so good. In fact, I had an out-of-body experience. Venkat got up and hugged me and said, this is awesome code. Well, a few weeks went by, and I saw this email on the mailing list in the client site. They said something terrible has happened in production. I looked at it, immediately responded saying, I'm on it, I'll fix it. And somebody said, oh, we know you'll fix it because you're really good. I said, no, I'm going to fix it not because I'm good. I'm going to fix it because I'm the one who caused the mess. Well, that brilliant solution I put together completely failed. And what did I do? I rolled back the change I made, put the 10-minute solution, and it worked, and never heard back from them about this ever again. Well, I learned an important lesson. These days, when I write a piece of code, my little brain says that's clever, I delete it. And I start over again. I don't want to write clever code, I want to write clear code. A beautiful quote by Abelson and Sussman. Program must be written for people to read and only incidentally for machines to execute. What a beautiful thought here. So you don't want to write the code for machines. It's really the humans we communicate with, and you want to make the code really easy for humans to understand. Well, I'm going to say 10% of the time, we write ugly code for performance reason. The other 90%, we write ugly code just to be consistent with the rest of the code we are writing. So when people tell me they need to improve the code because of performance, write the code that way, I don't believe it. In fact, this is so true that I'm to the belief that those who sacrifice quality to get performance may end up actually getting neither. And then we end up with a code that's horrible and nobody can understand, nobody can improve its performance either. So with that said, I'm going to say, the next thing I want to talk about here is applying Zinsser's principle on writing. Now, this one is a little strange because, we look for guidance in programming books. But I really came up with this guidance of refactoring from not a programming book, but a book on English. Well, this book was published about 30 years ago called On Writing Well by a gentleman named William Zinsser. Mr. Zinsser passed away a few years ago, but he left something absolutely remarkable for the world. And I admire this book because this book talks about how to write good English. Now, as I was reading this book, I came across not just inspiration to write better English, but actually to write better programs as well. I started speaking English when I was about 17 or 18 years old. So the first few years was really hard for me because English is not my native tongue. It's really hard to learn a language and then become proficient with it. When I started writing my books, the first person who had to read my book, that person was not called an editor. He was called a victim. And he came to me and said, "Is this your last book?" I said, "No, this is my first book." He said, "I'm in trouble then." And he gave me this book and said, "Don't write another word until you read this book." I'm very thankful for that because this really made a difference. In this book, Zinsser talks about 4 principles for writing good English, but I'm sure you would agree those 4 principles are not just for writing English, but it's for writing code as well. The first principle he talks about is a principle called keep it simple. He says that the writing you do should be really simple, but isn't that true? That's what we focus on writing code as well. He talks about clarity. If what you're writing is not clear, nobody's going to understand. That's what we struggle to do in code as well. Why is code not clear? Maybe too much mutability. Maybe there's not a good flow. Maybe the function is too big, or maybe written in the wrong place. So many things to make it really hard to understand. He talks about brevity. Shorter sentences better than longer sentences. Shorter paragraphs better than longer paragraphs. Shorter chapters better than longer chapters. But that's what we talk about as well. Shorter functions better than longer functions. Shorter classes, even shorter applications and components are better. And the last thing he talks about is humanity. And this is the one I had the most difficulty with because, humanity, we write code for machines to execute. Why do I care about humanity? It turns out this is one of the most important things because we often write code for other programmers to maintain, and so humanity is extremely important for us to consider in programming as well. So I treat these 4 principles not just golden rules for writing good English or any language for that matter, but for writing code as well. The next thing I'm going to talk about here is comment why and not what. Now, this is one of my pet peeves. Don't get me wrong. I'm not saying don't write comment. But I'm emphasizing write comment to tell me why the code exists, not what the code is doing. But we live in an insane world today because people are writing all kinds of stupid comments, and you always wonder why do they do it. For example, the other day I saw this beautiful code with a nice increment next to it. And when I see this, I always thank the person who wrote it because these are the grandchildren in the industry. And they know that Venkat is becoming a grandpa. He's having difficulty seeing things. What if his glasses are getting weak? So they put a little comment to say, Grandpa Venkat, just in case you don't know, this is called an increment. The point is, why did we increment? That's what we don't know. Or this X with the 2 with this beautiful shift, but why are we shifting? Now, you may ask the question, why do people write stupid comments like this? Well, I'll tell you why. That is because we've been taught really bad things and forced to do bad things. Before I say that, I'll make a little clarification. Not only do I work in the industry, I also teach part-time at the university. I've been a faculty of computer science for about 30 years now. And having said that, I'll say, part of the reason why people write such a bad code is because of the professors. They've been teaching really bad stuff over the past few decades. And they tell you to write comments. You tell them, but professor, I write readable code. And the professor says, if you don't write comments, I'll fail you. So we start writing really bad comments. And then you join company, what happens? Good news, companies don't have professors, but they have corporate police, and they have a coding standard. For every 5 lines, 1 line of comment. If you don't do it, you don't get the bonus. And so we are forced to do these bad habits, and it gets worse over time. So what can we do about it? Well, when it comes to comments, we need to ask the question, what do we want to really communicate? Don't compromise to cover up bad code with comments. When somebody tells me I don't understand this code, write a comment, I say timeout, I don't understand this code, refactor it, don't write a comment. So I don't want to be commenting code which is written poorly, I want to refactor it. And write code that's expressive and self-documenting code as well. And I'm going to say a good code is like a good joke. And trying to comment a code is like explaining a bad joke. Now, this is one thing I've done really well in my life. If there's one thing I've contributed, it is teaching my children never ever to explain a bad joke. Because if you ever say a joke and nobody understands it, what's the worst thing you could do? Start explaining it. And then people look at you and say, really? What's funny about it? Let me re-explain. This is going to be a very long dinner, isn't it? So you say a joke, nobody understands it. You immediately say, never mind. And then you go home, sit in a corner, think about why that joke did not go well. And you refactored your joke and tried with a new set of people. That's exactly what code is. You're trying to comment a code is like trying to explain a bad joke. You just want to lay it out and walk away, and people should understand it. Now, this reminds me of an experience. I was in Washington, D.C. to speak at a conference. And I said to myself, I'm going to shower before I go give a talk, which is a good thing to do. And I went into the shower. Well, these days when you're angry, you don't shower. You tweet about it. Well, I got into the shower, and I was so angry because I saw this, and I was intellectually insulted because these clowns wrote on the wall, pull to turn on. Like, why? And I immediately got out of the shower, took my phone, took a photo, and here's what I tweeted. And this is what my tweet said. Those who cannot design are condemned to document. So if you can design a system really well, you don't have to document the heck out of it. This has gone worst over time. Everywhere we turn, they want to document. You go to the door, it says pull. And like, why can't you just design the door so I can pull it without reading it pull? And this is even worse. The other day I had cold. And I told my wife I have cold, and she gave me a bottle of medicine, pills. You know what? I should have listened to her and swallowed it. But I did something terrible. I started reading what was in the bottle. Bad idea. Because the bottle said, take 2 tablets by mouth. And I'm thinking, what other options do you think I can exercise right now? So this is terrible. We want to document the heck out of everything in the world. So if we can design in a nice way, we don't have to document so hard. Order 3, what in the world is that? Oh, comment, large coffee. Or maybe we can write it in a way we don't need that stinking comment. We can design it into the code itself. Maybe that'll help us. So document code using well-chosen meaningful name. Use comments as to describe its purpose and why it exists, and describe the constraints, not to tell what the code is doing. Don't use comment as a substitute for good code. Avoid long methods. Now, let me ask you this question. Please raise your hand if you think long methods are a good idea. Not a single person raised the hand. That's awesome. Let me ask you a completely different question. Raise your hand if you see long methods at work. Now, that's beautiful, isn't it? This is called cognitive dissonance. I've got a good news, and I got a bad news. The good news first. You didn't do it. I mean, you just told me you don't believe in long methods. Here's the bad news. The people who believe long methods are a good idea are at work today, making those methods longer as we speak. Now, this is a disease in our industry. We know long methods are a bad idea, and yet we see it. Why? Reminds me of an experience in Devox, Belgium. And in Devox, Belgium, huge room, beautiful theater. Maybe I had about 800 people in front of me. And I shouldn't have asked this question. The lights were on my face. I cannot see into the dark. And I asked the question, what's the longest method you have seen? Out of the darkness came a voice, and it said, 40,000. I said, oh my gosh, 40,000? Is that your entire class? And he said, no, one method. And I'm like, my gosh, one method with 40,000 of lines. He said, yes. I'm sorry, where do you work? In hell? And I asked him, how could you even imagine this? And as I was finishing my talk, the gentleman comes up to me and he says, oh, Venkat, I'm the one who said 40,000 lines long. I'm not kidding with you. I can see in his eyes. He meant the truth. And I looked at him and said, 40,000, huh? And he said, no, it's worse than that. I said, how could it be worse than that? He said, because I didn't know this. But after I joined the company, that's when they told me my full-time job used to refactor that one function. And I'm like, my goodness, I didn't know such a job even exists. What's your title, by the way? Director of Sucky Code? And a full year went by. In the same auditorium, I'm putting together my talk, getting ready to give my talk. Gentleman walks over and says, hey, Venkat, do you remember me? I said, how could I ever forget you? And then he said, I don't know why, but since the morning I have a brotherly love towards you. I got to tell you how things are. I said, I'll be a brother today. I'll be a brother any day. How are things going? He said he's worked on it full time, and he's down to 30,000 lines now. We both agreed we'll meet one day to celebrate when the function has 0 lines of code. Well, we definitely don't want to have these long methods because long methods are really insanely complex and hard to really maintain. There are several things we can say about long methods, why they're really bad. Now, how long is really long method? Well, if I tell you 1,000 lines is long, you might say, of course. What if I say 100? Java programmers are happy with 100 lines, maybe not Ruby programmers. What if I say 10? Ruby programmers are okay with it, maybe not Clojure or Lisp programmers. Well, you cannot bring 2 people into the room and make them agree on what a long method is. Now, the other day somebody tried to tell me what a long method is or not. And he said, if you can see the entire function in a screen, it's not long. And then somebody asked him the question, what's your font size? There is no way to win this battle. Well, it turns out the long method is really not about the length of the method. It is a number of levels of abstraction in the method. So if a method has fewer levels of abstraction, then it becomes easier to comprehend this. So you want to really focus on the single level of abstraction rather than the length of the method. Look for the number of levels of abstraction or the nesting we normally put into the code. We want to choose really good, meaningful names for variables and methods. I'm going to say programmer is one who can name their children quite easily, but has a hard time naming their variables. I mean, would you do this? Would you name your child P? Right? Child, what's your name? P? Is it your initial? No, that's my full name. I got this theory. If somebody has a weird name like that, both the parents are programmers. Because if one parent is a programmer, the other one would be sane and say, of course not. When both the programmers are programmers, gosh, could be a single variable name for a child. Well, we give really good names for children, but why do we give such a bad name for variables? Well, this reminds me of an experience I had with a client. I was working with them. When we were doing code review, I saw a piece of code. I said, do you mind if I make a photo of it? And they said, if you don't tell who we are, go for it. I said, absolutely, I will never talk about it. And I took a photo. And here it is. I'm sorry, not this one. What I wanted to take a photo was the line below this line, in production code. Here's what it said. It said, God help me. I have no idea what this means. And I asked him, why is this still in the production code? He said, we left it out of respect for the guy who wrote it. And this is kind of unbelievable if you have to work with code like this every single day, and you have to maintain software written like this where you have to maintain these kinds of variables. So we have to respect really variable names. That's part of being professional, is to give really good names for our abstraction, and that is part of our responsibility. Variable names represent abstraction. If we cannot name a variable or a function appropriately, maybe we just haven't understood it, and we need to really spend more time understanding it. And of course, I'm a huge fan of code reviews. You may ask the question, are you crazy? Code review. Well, yes, I'm a big fan of code reviews, but people often do it wrong. Maybe you sent an email to the team saying there's a code review, and the boss comes running to your desk and says, did you just send an email, there's a code review on Thursday? And you say, uh-huh. And the boss says, heck no. Last time we had a code review, there was a fight, and we had to call the cops, and 2 people quit. No more code review for you. Well, code reviews unfortunately turn into a very political nightmare. But I love code reviews. That's why I call it tactical code review. So what is it? We never meet in a room to do a code review. We write a piece of code, and then one person reviews the code I write today. Another person reviews the code I write tomorrow. We just share one person reviewing the code, not in a meeting room, but just at their own desk. And they give a feedback, and we respond to it and move forward. Now, I do a lot of code reviews, but there are a few lessons I've learned over time. The first lesson I've learned is, I don't review the code first. I review the test, and then I review the code. Secondly, keep in mind there's always a human on the other side. So don't say bad things when you review the code. Don't say things like, gosh, I'm looking at this code. It smells worse than a garbage truck. Instead, give positive feedback. Hey, I'm wondering if we should break this method into smaller methods maybe. And of course, the third thing to think about is, when I started reviewing the code years ago, when I found a bug, I used to write a description of the bug. Then I realized, why not write a test rather than writing a description? I started writing tests and committing the failing test when I find a bug. And that's been a very effective way, not only to point the bug, but also to tell the team, you write test when you find a bug, and not just fix the bug and walk away. And secondly, when you are reviewing the code, when you do it this way, sometimes you think something is a bug, but it's a misunderstanding. And you end up really refactoring the code because there's not a bug, there's just a misleading code that can be really helpful. So we do this tactical code review quite often, and it's been very effective for what we do. And the last thing I want to say here is reduce state and state mutation. Maybe this is an influence of functional programming on me, but I used to write a lot of bloated objects with a lot of state. Today, when I sit down with my clients, they write public class, and the first thing they do is private and put the field. And I ask them, why are you writing the field? And they shrug and say, because I need it. No, we don't. I don't want the state to be self-serving. I want the state to be brought in by a behavior. So I focus on writing tests for a method. And only when the method's behavior demands a state, very reluctantly, I bring in the state. Here are a few reasons to think about it. Think more, type less. Aim for minimalism, fewer state, less mutability, just enough code for the known, relevant parts of the problem. I'm going to say messing with state is the root of many problems, both in software and in politics. If we can leave state alone, life is a lot better. And of course, mutability needs company. It often hangs around with bugs. So more mutability we have, the more difficult it is to reason the code. It becomes hard to maintain the code as well. So we talked about 12 different ways to make the code suck less. Now, you may be familiar with a lot of those things. Hopefully, it gives you a few pointers to take home and try them, and maybe a few pointers along the way that you could rethink about what you do. We talked about scheduling time to lower technical debt, favor high cohesion, favor loose coupling, but eliminate coupling where you can, and program with intention, avoid primitive obsession, prefer clear code over clever code, apply the principle of writing to principle of writing code, comment why the code exists, not what the code is doing, avoid long methods, follow the single level of abstraction principle, give good meaningful name for variables and methods and classes, do tactical code review, and reduce state and state mutation. If I can leave one departing thought with you on that, I'm going to say the first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right on the first write. Code is written once, but it's rewritten thousands of times, if not more. And we always write code once, but read it several times. So it's the readability of code that's important, not our ability to write it in the first place. So it's really important to take the time to improve the quality of code and make it better along the way. Hope that was useful. Thanks for joining.